Did you get confused at the point while trying to solve problems on permutation? I guess solving problems on permutation could really be confusing, especially when conditions are given. Well, if so, no worries. This video is set to provide a simplified method you can use to solve problems containing either of the following conditions. 1. When items must be together. 2. When items must not be together. 3. When a particular item must end or start an arrangement. Let's go on to solve problems containing these conditions. The first problem we have here is, in how many ways can the letters of the word excellent be arranged if the three E's must be together? To solve this, first find the number of ways the three E's can be arranged since they must be together. Assuming the three E's are different items entirely, they can be arranged in 6 different ways, taking one at a time. This arrangement can be denoted as 3 factorial. However, the three E's are alike in every aspect, hence they are identical items. Since they are identical, only one order of arrangement will be taken into consideration, and this order of arrangement is denoted as 3 factorial divided by 3 factorial. 3 factorial as numerator because there are 3 E's. 3 factorial as denominator because of the number of repetition. Simplifying 3 factorial, we get 3 times 2 times 1, and this will give us 6 divided by 6, which is equal to 1. This means there is only one way to arrange 3 E's since they are identical. Now that we know how many ways the E's can be arranged, let us consider the arrangement of the letters in the word excellent. Generally, there are 9 letters without any restriction, but since the 3 E's must be together, consider them as a single letter. So the total letters will become 7, with the letter L being repeated. The number of ways to arrange these letters is 7 factorial divided by 2 factorial. 7 factorial because there are 7 letters considering the 3 E's as a single letter. 2 factorial because the letter L appears 2 times. Simplifying 7 factorial divided by 2 factorial, we will get 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 2 times 1, which is equal to 5040 divided by 2, which is equal to 2520. Since the 3 E's can be arranged in just one way, let's multiply this answer by the number of ways the letters that must be together can be arranged, that is 1. So 2520 times 1 will still give 2520. Therefore, there are 2520 ways to arrange the letters of the word excellent if the 3 E's must be together. Let's solve another problem. In how many ways can the letters of the word smart be arranged if A and T must be together? Same way we solved the previous problem. Let's first find the number of ways A and T can be arranged. There are only 2 ways to arrange A and T, since they are not identical items. This order of arrangement is either AT or TA. Now that we know, consider A and T as a single letter in the given word. The letters in the word smart are generally 5 without any condition. But if A and T must be together, there will be 4 letters with no letters repeating itself. The number of ways to arrange these 4 letters is 4 factorial, since no letter was repeated. 4 factorial is equal to 4 times 3 times 2 times 1, which is equal to 24. Multiply 24 by the number of ways A and T can be arranged, which is 2. So 24 times 2 is equal to 48. Therefore, there are 48 ways to arrange the letters of the word smart if A and T must be together. What if we were given problems when particular items must not be together? Problems like, find the number of ways the letters of the word better can be arranged if the 2 T's must not be together. How do we solve this? Whenever you are asked to find the arrangement when particular items must not be together, use the concept when item must not be together is equal to general arrangement without any restriction minus when the items must be together. So what we need to do is to find the general arrangement first. There are 6 letters in the word better, with 2 letters E and T being repeated. The number of ways to arrange these letters is 6 factorial divided by 2 factorial times 2 factorial. The 2 factorial at the denominator represent the repetition of e and t in the word. 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1, which is equal to 720. 2 factorial is equal to 2 times 1, which is equal to 2. So 2 factorial times 2 factorial is equal to 4. When we divide 720 by 4, we will get 180. Hence, there are 180 ways to generally arrange the letters of the word better without any restriction. Having done that, let's find the number of ways the letters can be arranged if the 2 T's must be together. To do this, arrange the 2 T's first before arranging the others. Since the 2 T's are identical items, there is only one way to arrange them. With that in mind, consider the 2 T's as a single letter in the word better and find the number of ways the letters can be arranged. So there are now 5 letters to arrange with E being repeated. The number of ways to do this is 5 factorial divided by 2 factorial, which is equal to 120 divided by 2, which is equal to 60. Multiplying 60 by the number of ways the 2 T's can be arranged will be 60 times 1, which is equal to 60 ways. Hence, there are 60 ways to arrange the letters of the word better if the 2 T's must be together. Recall from the concept, when the 2 T's must not be together is equal to general arrangement without any restriction minus when the 2 T's must be together. This is equal to 180 ways minus 60 ways, which is equal to 120 ways. Therefore, there are 120 ways the letters of the word better can be arranged if the 2 T's must not be together. Let's solve a problem containing a different condition. In how many ways can the letters of the word study be arranged if it must begin with the letter D? This condition is different from all problems we have solved so far. So how do we go about it? Whenever you are asked to find the arrangement when a letter must begin or end a word, always fix that letter at the required position and arrange the others. So what we need to do is fix the letter D at the beginning of all orders of arrangement. There is only one way to do this. Once this is done, we can arrange the remaining letters taking one at a time. The remaining letters are 4 in number with no letter being repeated. The number of ways to arrange 4 different letters is 4 factorial, which is equal to 4 times 3 times 2 times 1, which is equal to 24 ways. There you go, and I hope you can now solve problems containing any of these conditions.